Now let's talk about changing molarity and molality. And it's going to we'll change gears a little bit. So that's how I'm going to actually make a solution. Now let's talk about what happens if they give me the problem in molarity, but I want it in molality, because molality is more useful to me down the road. Okay, so these I'm going to go through two example problems. These are hands down the hardest problems we do, but you'll notice they follow a very specific format. So it says hydrochloric acid is sold as concentrated aqueous solution. Excess information. If the molarity of commercial HCl is 12 and its density is 1.18 grams per cubic centimeter, calculate the molality of the solution. Okay, here's what I always do when I do this. I write down my formulas first. Molarity is equal to moles of, in this case, HCl divided by liters of solution. And molality is moles of HCl divided by kilograms of water. They didn't tell me otherwise, so I'm going to assume water is my solvent. Okay. There's information I know, and there's a lot of information I don't know. That's pretty much all I know, and that's a problem, because that left a huge hole in my knowledge. There's going to be an assumption that you have to make. And I'm going to make this assumption, and I'm going to explain why. When I do this, I'm going to assume 1 liter of solution. Now, why did I assume 1 liter of solution? Well, remember that molarity and molality are ratios. They are a ratio of moles of something to either liters or kilograms. As long as my ratio stays constant, it doesn't matter how many moles I have, because the denominator will always balance it out. So I'm assuming that I have 1 liter. Well, look what happens when I put in 1 liter. Now, all of a sudden, I know my moles. And I now know that I have 12.0 moles of HCl, which is going to go up here in this calculation. Notice I insert it immediately so I don't forget to do it later. Now that's great, but there's still one piece of information that's missing, and that's the kilograms of my water in order to solve for molality. Okay? So there's one other piece in the problem that I haven't used yet, and that's the density. Density tells me that there is 1.18 grams in every 1 cubic centimeter. And remember that 1 cubic centimeter is equal to 1 milliliter. Well, I don't have 1 milliliter. I have a liter, which is 1,000 cubic centimeters. Well, if 1.18 grams are in every 1, then there would be, how many would be in 1,000? Well, that would be 1180 grams in 1,000 milliliters. Okay? So now this is really important, because now I can work with this. Now you say, wait, how? That's a really huge disconnect here, Mr. Siegel. And you're right, a little bit is, but I'm going to show you the connection. This 1180 grams is equal to the grams of my HCl plus the grams of my water. Well, I need grams of water, because that's what I'm going to put up here in the kilograms. Do I have grams of HCl? I don't have grams of HCl, but I have moles of HCl, so let me do a quick conversion. Slide my calculator back over, out of my way. It's 425.4. Oh, that's not the right mass. First of all, I'm going to use the correct mass of HCl, which is 36.45. 46. Erase. Because 35.45 plus 1.01. I know, it doesn't seem like it's all that big of a deal, but sometimes it is. 437.52. Okay, so now my 1180 minus 437.52 is equal to the grams of my water is 742.48. Which would be 0.74248. And then my last thing I love these fancy calculators. They let you do all sorts of fun stuff. Is 16.2 molality. Okay? Now, notice what I did. I did a whole lot of work all over the place. Okay, so what do? First thing is this key factor right here. Assume 1 liter of the solution. When you do that, that will tell you immediately how many moles of solute you have. Plug your numbers into your formulas as you go so that you know what you're missing. Density tells you total mass or the total volume. Okay? So I'm going to use that information to find my water. And that brought me, I used my moles, which I calculated over here, to find the grams of my solute. Used the grams to find my grams of my water. I then took that information, plugged it up here, and that helped me solve my molality. Let's do one more example just to help you out a little bit. Concentrated aqueous ammonia has a molarity of 14.8 and a density of 0.90 grams per cubic centimeter. What is the molality of this solution? Okay. Molarity. Again, pause it if you think you know what you're doing, and then come back and see how I solved it to see if what I did and what you did are the same. Okay? Because I'm given molarity here, I am going to assume 1 liter of solution. Okay. So, if I assume 1 liter, that means this is 14.8 equals X moles over 1 liter. X equals 14.8 moles of NH3. Let's actually use the number that I gave. Okay. I know my density is 0.90 grams per 1 cubic centimeter, which will be equal to 900 grams per 1 liter. 900 grams is equal to grams of NH3 plus grams of H2O. I don't have either of these. I want to find the grams of H2O. So I'm going to take my 14.8 moles of NH3 and I'm going to convert it to grams. So 14.8 times 17.04 is 252.192. 252. Sig figs are not super important here, because again, what you write down and what you use in the calculator are two different things. $647.81 divided by 1,000. That's just me converting to kilograms over here. 22.8. Okay, so again, notice the process was exactly the same. How you do it doesn't change. It's just the numbers that are going to change. And that's how you change from molarity to molality. Again, hands down, hardest problem we do in this whole unit. So if you're struggling with this, lots and lots and lots and lots of practice. Okay?